Hi, I'm Mark Habib.
I'm Spencer Gump, and we're going to discuss a negative externality.
A negative externality occurs when two parties don't have to pay for the full cost of their decisions, and this external cost is attributed to a third party not involved with the original transaction. The externality we're going to focus on today is on the effects of excess use of nitrates and phosphate fertilizers in the Mississippi River Basin, as well as the dumping of sewage water into the Mississippi River by communities along the Mississippi River. This has led to unnaturally high levels of nitrogen and phosphate in the areas of the Gulf of Mexico.
The Mississippi Atchafalaya River Basin drains 41% of the continental United States. This accounts for 90% of the total freshwater input into the Gulf of Mexico. This stretch of river is the second largest human-caused coastal hypoxic area in the global ocean. The term hypoxic means lacking oxygen, and if levels fall below 2 milligrams per liter, then this area will be considered hypoxic.
The nitrogen from these rivers creates abnormally large algal blooms that use up all of the oxygen in the ocean water, creating dead zones where there's not enough oxygen for marine life to survive. The dead zone was originally discovered in 1972 and has appeared every spring and summer since its discovery.
These hypoxic conditions disrupt the food chain, causing species high mortality and loss of biodiversity in the area. This reduces the amount of marine life present in the Gulf, negatively impacting fishermen and other persons making a living from the Gulf. The Gulf accounts for almost 1/5 of the nation's commercial fish landings and just over 1/5 of the $3 billion total value of these landings.
There are many relevant factors in this externality. Farmers in the Midwest leaking fertilizer in communities along the river, dumping their untreated waste into the Mississippi River.
The Economic Research Survey estimates that 2/3 of the nitrogen in the Mississippi River has come from the use of fertilizer and manure for agricultural purposes.
There are many people causing and experiencing the effects of this negative externality. Farmers in the Midwest leaking fertilizer into the groundwater table and communities along the river dumping their untreated waste into the Mississippi River are both causing these outcomes.
The Economic Research Survey estimates that 2/3 of the nitrogen present in the Mississippi River have come from the use of fertilizer and manure for agricultural purposes.
Because of this, fishermen are now making less money because there's less marine life to be caught.
Communities downstream are also experiencing negative health effects due to the increased nitrate and phosphate levels in the water, as well as an elevated level of treatment of the water in order to make it usable with increased costs to the community.
There are many government resources being used to evaluate and assess the impact of this negative externality on the Mississippi River. The U.S. Geographical Survey and the U.S. National Oceanic and Atmospheric Administration have been forecasting algal blooms using computer models. The U.S. Geographical Survey and U.S. Environmental Protection Agency have been going to hundreds of creeks and rivers between the Ohio and Nebraska area to test for hundreds of pesticides and nutrients used in farming and check for their possible effects on the living organisms in those streams. These measures take up a great deal of resources, costing the U.S. government millions of dollars.
There are many issues involved with this externality. Farmers, first off, need to be held more responsible for the runoff of their pesticides and excess fertilizer into rivers, streams, and the groundwater table. A stronger enforcement of proper water treatment and sanitation for these communities along the river will help in the long run. The river is not there to be used as a dumping site, and policymakers cannot allow them to treat it as such for any longer.
Another way would be to change the timing and process of fertilization so that rainfall will not wash as much of it away into rivers and streams. Also, with laws like the Renewable Fuel Standard, Midwest farmers are forced to use a greater amount of fertilizer. Under this mandate, U.S. total production must surpass 15 billion gallons of corn ethanol, and to meet this standard, 5.3 billion bushels of corn need to be produced, or to put it in production terms, approximately 40% of the 2011 production. Because of these quotas that need to be met in corn production, farmers are forced to use excessive amounts of fertilizer and pesticide to meet the quotas. If it weren't for mandates like this by the U.S. government, farmers would not be forced to produce as much corn to meet the demands of consumers, and therefore would have less of an impact on the surrounding rivers and streams.